Good evening, everybody. My name is Ken Collins. I'm with Skkynet Cloud Systems, and I'm going to walk you through a video that introduces our platform for delivering secure end-to-end cloud solutions for real-time data. The problem we've all talked about in here, everybody knows, we've got industrial systems or maybe we've got financial systems, and we need to be able to share that data with other systems, or maybe we want to look at the data in a browser in a remote location. And often we need to be able to aggregate that data and mash that data for more intelligent consumption. Some of our customers are looking for solutions for the latest in embedded systems and small standalone devices. And others are looking to leverage and extend their traditional office and decision support systems into new areas. And of course, we want to do all of this in the cloud where we've got all these concerns, from speed and security right through to ease of use for the manager, the user, the operator. And these concerns become really difficult to address because as soon as you put a firewall in front of everything, this can solve your security problem, but boy, does it sure make it difficult for remote access and collaboration. But we need those firewalls. We have a solution. I'm waiting to make sure my video's playing. There we go. We believe we have a solution. This week here at the show, we actually are launching our secure cloud service. And it is a real big differentiator for us. Let me explain how that works. Firstly, we need to protect our key systems. We need those firewalls. But we still need to enable connectivity and data distribution. And there's lots of different ways to do that. We have a product called the Cogent Data Hub, which is an established middleware product for data acquisition, aggregation, and data distribution, and it works configured with your existing systems. For embedded systems, if you're looking for help connecting that to the cloud, we have an embedded toolkit. And the embedded toolkit comes with source code, and it can work with those embedded systems, push data directly to the cloud today. In the world of the cloud itself, we've also got Skkynet WebView, which is our web HMI, drag and drop in a browser, and the Skkynet portal to administer the service, administer your users. Here's a real big key. We cannot open our firewalls, so we have a solution that is totally closed. There are no open inbound ports for your firewall at all. But you push the data by initiating that connection request from inside your systems, pushing that out. And because there are no open firewall ports, there is no attack surface. There's no denial of service ability, nothing, because there is no attack surface into the plant whatsoever. The key to this is that even though the connections are open from inside and they're directional out from the plant, you have complete bidirectional data flow and control. Once you've established a secure session, a secure connection, data can go in both directions. And that means you can have your industrial system on the far left with an outbound connection only, communicating with another remote system with an outbound connection only. Okay? I'm going to give you a demonstration. I think I'm going to give you a demonstration. Here we go. So right here I have a plant in Japan. Now, for demonstration purposes, it's not really a plant. It's actually a virtual machine. But it really is in Japan, and it really is behind a completely closed firewall. So this represents my data source. We've installed and configured the Cogent Data Hub to acquire and aggregate that real-time data. And so this Cogent Data Hub product is providing all of that real-time capability. And so you can see that, for example, right here, and I know it's a little bit hard to see, but I have a single data domain that represents my plant data. It's a single wind turbine that I'm calling WTA1 right now. And you can see in the top right corner there that data is changing in real time. So that's the source data that I want to push out to the cloud. So the first thing my customer is going to do is go and open up the Skkynet portal. And the Skkynet portal allows me to register for the cloud service. I can create and control how I want to emit that data. I want to be able to choose the service level, so I can choose the right level for process isolation, for data isolation, all self-serve. It's also a completely configurable solution. So you administer it yourself with user permissions, completely up to you how you want to indicate, whether operators, what kind of level they can, what kind of control they've got of the real-time data. Is it read-write? All that kind of thing. So we use the portal to administer that service. So we're going to go back to Japan. We've now got to a point where we have our real-time data. We've registered for the secure cloud service, and we've already chosen the DNS name and the data domain we want to push that into. So right here up on the screen right now, you can see that I am configuring what we call a tunnel or a mirror. And so right here on the screen, we are specifying we want a WebSocket connection. We've indicated what the credentials are. This is now going to push that data out to the cloud. So we're using WebSockets to provide that connectivity because, of course, that means we can encrypt it using SSL or anything else we need. And it's going through, in this case, port 80. So it's this data that we're going to push out to the cloud right now. So as soon as I come down and hit apply on that, I can see that my status has changed. That data is now being pushed out. You can see the status of running. So I'm now going to flip over. I need to be able to consume that data. So I'm going to launch the Skynet WebView, which is our solution for building a visualization solution for real-time data. There's lots of different web HMIs out there for SCADA systems or whatever. In this example here, all we're doing is very quickly building a screen where we're binding controls, labels, gauges, whatever you want. And please remember, this data is coming from Japan in real time, okay? And all of this is being done in our browser. We've got hundreds of different controls from labels and gauges, 4,000 different symbols. So just very quickly, an example of how we're going to build the screen. And a key differentiator here, this is entirely in the browser. There is no software to install. You simply go home, build a page. How do you deploy a page? You hit save. Okay, very straightforward. I indicated earlier that we have our systems opening those secure connections. Well, here I'm just going to reorganize the screen a little bit. You'll notice on the left right now, I've got my web screen. I want to bring Japan back into the picture here. So you can see that what I've done is I've just stabilized my data. I've turned off auto mode. In this case, this is in real time. You can see that I've actually manipulated the source data by specifying, change the rate, the frequency of data generation to 1 hertz. I'm going to bring Japan back into the picture. So I've got my source data over here on what's now your left, and I've got my gauge on the right. And as I make changes by clicking auto mode, you'll see the button in Japan flipped over. If I want to change my data generation frequency, I can change it from 1 to 5 to 10, and you'll see again, over on the Japan side, down in the bottom there, update frequency, that's changing. Here's the key message with this. We're pushing the data through an outbound firewall connection, but the data flow and control is bidirectional. Absolutely no open ports in the firewall. No VPN. This is using nothing but WebSocket connection over the internet. Okay? That is not sped up video, that is real time. That's the speed at which this data is being generated right now. So you can see I can click stop and start, and that data is handled. I'm just advanced here a little bit. We've got lots of different controls. You can see right there, I've got a map. I've got, you'll recall that one wind turbine, WTA1 running, and so I'm using this map control as simply my selector. I'm going to flip back over to Japan for a second with my simulated data source. I'm going to shut down that single wind turbine, and I'm going to start up 7 wind turbines. to demonstrate data aggregation. I'll come back and you can see now my wind turbines are starting up, and I can now click on the different turbines and I can see the data there. You'll also notice that for WTA 6 and WTA 7, it's just now starting to build history. In the case of going back to WTA 1, I've got all that historical data there because it had been captured previously. I'm going to pause on this screen just for a second because I want to also illustrate the extensibility of this platform. This gauge, this compass, I guess it's on this side, this compass that you see over on the bottom right-hand side is one of my favorite because this solution is entirely extensible. If you have a control that you want to use that represents your business or your process, go build it. That compass is entirely XML. And there are about 50 moving parts on there that entirely are bindable to data. Okay, so all of our entire control architecture is based on an XML model. We've also got integrated script capabilities, so you can see that really allows you to generate some interesting animation effects. I love this page. It's got a really nice user experience. As I change data points, remember we're going directly back into the plan. Another couple examples of pages. This one here is a water treatment facility, and I like this one because it also demonstrates how many different symbols we've got. Literally over 4,000 different symbols we can put on screen to support industrial, financial, all kinds of different kind of systems. This next one was generated at the request of one of our customers who wanted really good detail for a wind turbine. Okay, so again, this is real-time data. You'll notice that even though these pages kind of get shrunk and moved over to the toolbox, all of that is live. And if you were to zoom in, you'd see that they're still reacting there in real time. Okay? So far what you've seen here is really machine to user or machine to visualization. And you can see, by the way, here's just another virtual machine. This one's running in Ireland. So in this case, I've got exactly the same page deployed on a virtual machine in Ireland and the source machine, if you will, which was the one that I just built here. We live in Canada, by the way. And so you can see if we just organize these screens, the gauges should be totally in sync. That is not peer-to-peer, that's going through the cloud. So everything is based upon wherever the cloud service is designed and administered by the customer. And so as I move the gauges around, you can see the same data. The plant, I can come along and click the pause button, and as soon as I do that, wind turbine A1 stops. Okay? We've talked about machine to visualization. We also have a solution that is entirely machine to machine. One of the things that some of our customers want to be able to do is have their data in their one plant actually driving processes in a separate plant. Traditionally, how do we do that? Well, VPN solution or something like that. This example here literally took me 5 minutes to get installed. There's the same source data in Japan. I've got another virtual machine here running in Sao Paulo, Brazil. And in 5 minutes, I'm able to install the Cogent Data Hub. And you'll notice that in this case here, I'm just going to configure it. I've got exactly the same tunnel mirror. So this is about to establish an outbound WebSocket connection using the same secure credentials for this site. And I'm just going to organize it here. You're going to see that we're going to push that data. It's a little bit hard to see. We're pushing that data into a domain in Brazil called Japan Wind Farm or Japan WF. And I'm just going to get you to wait 1 second. There we go. So if you look over on the top right side of our screen, this is something called our data browser. And right now you should simply notice by absence, there's nothing there called Japan WF. There's a OPCAE and a default. I'm going to come back over and I'm going to then turn on that tunnel, which is going to initiate the request. And as soon as I do that, you'll see it created the Japan WF data domain. Folks, that is real-time data coming from Japan. That's machine to machine. Got it? Excellent. Next 30 seconds or so is about small systems. So when we talk about the Internet of Everything, the Internet of Things, if you're looking to take your small devices, your chips, and push data directly to the cloud, we can help. We've got an embedded toolkit that we've tested a number of different systems. Come by our booth, we'll show you a Raspberry Pi. You can see a Sakura, Arduino, all those kinds of things. These devices are pushing data directly to the cloud. And because it's in the cloud, we can now use another component of our platform. Again, you've seen it, Skkynet WebView. And so you can see this is an example of accelerometers and illuminators and all kinds of things that are just pushing that data up. I'm going to pause right there because the next one's really cool. How much time do I have? I'm doing it? Good. So one of our engineers got really excited by this, and 2 weeks ago he takes his kids out onto the street. Pay attention to this one, because I've never seen anybody else on the planet doing this. You ready? He goes out and he buys a Parrot AR drone remote control helicopter. And in the matter of an afternoon, he built some screens and a device driver. Folks, he's flying that through the cloud. The cloud server, now it looks as if he's flying it from the machine. Well, he is, but that's the control interface. And as he moves his finger around, watch this thing. The cloud server is in the eastern United States, 500 miles away from his home location, which is Mississauga, Ontario, Canada. That's real time for us. We're not talking every 5 seconds. 50,000 data point changes per second. Okay, now, not in this example. Okay, so that's our platform. Thank you very much. Come see us. We're at booth 714. Appreciate it. Thank you.